The first energy system we're going to be looking at is the ATP system. This is an anaerobic system where it doesn't need oxygen, and it is also stored in the muscles. The system releases energy by having one adenosine and three phosphates. Connecting these are high energy bonds, which are stores of energy. A bond gets broken by enzymes, which are called ATPase. ATPase enzymes. This causes a phosphate to disconnect from the ATP, which then makes the ATP become an ADP, as there's only two phosphates instead of three. Therefore, when this bond is broken, energy gets released and heads towards the sliding filament theory. This is where the myosin and actin in the sarcomere of the muscle slide along each other to cause contraction, where the energy is needed. ATP can only last for 3 seconds, so it needs to be resynthesized. This is where phosphocreatine, also known as PC, which are also found in the muscles cells, which is given to the ADP to form ATP again. And the cycle will be shown. Then shown. ATP lasts for around 3 seconds. Therefore, it will be used in sports with a high intensity, such as a 100-meter sprint, but only at the beginning. This is a low duration, whereas other systems, such as the aerobic system, will be used in longer durations, such as a marathon. Therefore, ATP is beneficial for short distance exercises, however useless for long exercises because it doesn't last very long. For the ATP to resynthesize, there has to be PC present, which is phosphocreatine. As PC delivers a phosphate molecule to ADP to form ATP, PT contains a phosphate and a creatine. They are found in the muscle cells. When the phosphate gets released from the PC to the only molecule left in the creatine, this high energy bond between the phosphate and the creatine gets broken by an enzyme called the creatine kinase. When the phosphate gets released from the PC, the only molecule left is the creatine. This energy gets released from the breakage of the bond, which goes towards the ADP, where it will build up so a high energy bond can be present. When the phosphate returns to the ATP, this system is very simply, however, it is essential for ATP in the muscles. The duration of this only lasts 7 seconds, so there is once again a low duration but high intensity. As a result, the energy system becomes ATP-PC, where all together it will last around 10 seconds. The ATP-PC system is active in the 100-meter sprint. However, the ATP system is only active at the first few seconds, and the PC is active in the last 7 seconds. Finally, the last energy system is the glycolytic system. This can be also named the lactic acid system. It is an anaerobic system and lasts around 2 to 3 minutes. The word glycolytic means the splitting of glycogen or glucose into energy. The system works by glycogen breaking down into glucose by enzymes called the glycogen phosphorylase. This glucose then breaks down into pyruvic acid through the enzyme fructokinase. When the glucose breaks down, it will release enough energy to resynthesize 2 ATP molecules to carry on the system. Oxygen is needed for further use, and this system is anaerobic. Therefore, the pyruvic acid will just turn into lactic acid through the enzyme lactate dehydrogenase, where this causes a decrease in pH, meaning an increase in acidity. Unlike pyruvic acid, lactic acid is a strong acid that can cause discomfort to people, such as fatigue. This is why the more you exercise without oxygen, the more energy you need for your muscles, meaning the glycolytic system will be used more, which creates lactic acid. This system is very good for around 2 to 3 minutes and maximal intensity. Our class measured the blood lactate of 2 students in 2 different tests. The first student did the bleep test, which is, Motivated fitness test, and the other test was a Wingate test, cycling on the spinning bike for maximally 20 seconds. Everyone's blood lactate is around 1.6 millimoles per litre. So at the start of both tests, the participants will start at 1.6. In the bleep test, the blood lactate increases dramatically from from rest to level 4 because when the glycolysis system is used after 10 seconds, it reduces the loss of lactic acid, which lasts around 2 to 3 minutes. Therefore, the more amount of the glycolytic system is used, then the more lactic acid is produced, causing the blood lactate to increase all the way to the post-test. The end result is around 19 millimoles, which is quite high because the glycolytic system will be getting used more frequently to produce more energy than before to try and keep the student in high energy. This shows that they were more fit, the less lactic acid you would produce. This is very similar to the Wingate test, as the lactate also rises at the post-test around 21 millimoles. A glycolytic system may only last around 10 seconds, but its maximal intensity, therefore, is resynthesizing the ATP as quick as possible to provide the most energy. Lactic acid is a waste product in the body, meaning we need to get rid of that, and that's what we do by blood taking the waste product around our body and back into the atmosphere, meaning after while at rest, lactic acid will reduce back to 1.6, as it would still get produced with small movements, but nowhere near as much as before when performing. Finally, in sport, many movements will need energy systems. Different movements require different energy systems due to the intensity and duration. For example, in a sprint or dribbling with the ball in football, you'll be at maximum intensity, but it can vary how long you're running. If you're running down the wing with the ball, you would be running for around 10 seconds, meaning you'd be using the ATP-PT system. This is because the ATP-PT system lasts around 10 seconds, as the phosphocreatine is the immediate system that resynthesizes the ATP. The glycolysis system may be used in the run, last more than 10 seconds when perhaps running down the wing for longer distance or starting a counter-attack. It all really depends on the intensity and duration to determine which energy system will be used. Over the course of the full 90 minutes, the aerobic system will be needed the most, as you will need more oxygen so you won't fatigue quickly. Goalkeepers will always be using the ATP system 99% of the time, as they don't really do much for more than 10 seconds anyway. When exercising, your first system will always be your ATP system, followed by the glycolytic system and leading on to the aerobic system after 2 to 3 minutes, where the exercise will start to become a bit less forceful as you will be able to run easier. When the aerobic system, as the muscles are getting oxygen they need.